The steam and water mixture formed in the water wall tubes rises to be collected in the upper headers, and from here it passes into the steam drum. The steam drum is an important component of the boiler that has many functions. The first is to separate the steam from the water in the returning mixture. Mechanical separators are located along the inside of the drum to perform this task, which is usually achieved by centrifugal action. Steam enters the upper part of the drum, while the water falls to the bottom, joining the incoming feed water. This returning water, along with the additional feed water, then goes back into circulation once again along the following path. Down the downcomer to be distributed to bottom headers. From the bottom headers up the water wall tubes where steam bubbles form in the water, into the upper headers, and from here into the steam drum, where steam is separated from the water to enter the upper part of the drum. At any particular instance, we may have, say, 70% of the water in continuous recirculation, with just 30% being evaporated into steam. Of course, we must add feed water to make up for this 30%, which has been converted into steam. The feed water is normally fed into the steam drum through an internal distribution header, which runs along the whole length of the drum. Distribution nozzles feed water into the drum, usually in the area of the downcomer pipes. The objective of this is to provide the cooler water to the downcomers and so improve natural circulation. The quantity of feed water entering the drum is controlled so as to maintain the desired water level in the drum. Usually, automatic controls carry out this task by adjusting the feed water control valve or perhaps the speed of the feed water pump. The steam which collects in the upper part of the drum is saturated steam and will be at saturation temperature. For example, if the steam pressure in the drum is at 200 psi, its temperature will be 381 degrees Fahrenheit. At a pressure of 1000 psi, the saturation temperature is 542 degrees Fahrenheit. The water in the steam drum will be at a slightly lower temperature due to the dilution effect of the entering feed water. Steam is drawn off the top of the drum, and to make sure that this is as dry as possible, another set of steam separators or dryers are fitted along the inside of the drum at this point. We do not want to carry droplets of water along with the steam if this can be avoided. So we can see that the steam drum contains quite a lot of hardware. And in addition to that, there are a number of very important external connections, such as one or more safety valves, which will open in the case of excess pressure inside the drum. Valved vent connections, which allow air to be expelled from the drum during startup when the pressure is rising. Chemical feed injection, which allows us to inject certain chemicals to control the quality of boiler water. A blowdown connection permitting continuous discharge of water in order to reduce the accumulation of solids in boiler water. Instrument connections for monitoring and control of boiler operation. Gauge glasses, usually fitted at each end of the drum to provide a physical view of the water level in the drum. Steam connections from the top of the drum. Downcomer connections at the bottom of the drum. Means must be provided for draining the boiler of water in the case that certain maintenance work needs to be performed. For this purpose, large drain valves are fitted at low-level points such as the bottom drum, downcomer's low point, bottom water wall headers.